Hi everyone, welcome to TQS. In this video, we will show in detail the resources that TQS provides for structural analysis. The modeling present in TQS is aimed at multi-story reinforced and prestressed concrete buildings. TQS has several models for analysis, from the simplest to the most complex, which emerged with the evolution of modeling in structural engineering. Currently, the most widely used models are the grid for analyzing floors and the spatial frame for analyzing the building as a whole. In TQS, the engineer can choose to use the spatial frame model of beams and columns, combined with the floor grid or a complete spatial frame, with all the beams, columns, and slabs of the building in a single model. The most diverse types of loads are treated, including wind, shrinkage, temperature, prestressing, and thrust. Action combinations are automatically generated for dimensioning and evaluation in service, according to the defined standard. In TQS, modeling is performed with a focus on structural elements, and based on these and design criteria, the analytical model is generated automatically. After processing, all analysis results can be viewed quickly and transparently graphically or through reports. Below, we will present some characteristics of the structural analysis present in TQS. The complete spatial frame, with all beams, columns, and slabs, has nodes with 6 degrees of freedom. This makes it possible to consider even the forces in the slab planes. Its processing is carried out using the substructuring technique, which allows the analysis of complex models with more than 1 million nodes. For each building, TQS automatically generates 2 models, an ULS, for assessing global stability and dimensioning of elements, and the SLS model for assessing in-service performance, each with appropriate stiffnesses according to the loading level. TQS has a special model for transition beams, as this is a fundamental element in the safety of the structure. In TQS, wall columns can be discretized in the spatial frame, which allows the simulation of the effects of oblique compound bending and torsion in a more refined way. The rigid sections of the connections between the elements are automatically incorporated into the model. It is also possible to define plastifications by means of semi-rigid connections. TQS offers several types of analyses to consider physical and geometric non-linearities. In both cases, it is possible to adopt methodologies ranging from the simplest to the most complex, such as the use of moment curvature relationships and the p-delta process. The effect of sequential construction of floors in a building can be simulated in 2 ways: by increasing the axial stiffness of the columns or through incremental analysis. The assessment of global stability and calculation of second-order effects is performed using approximate methods or with refined geometric nonlinear analysis. In addition to linear analysis, it is possible to calculate deflections in pavements using a nonlinear analysis that takes into account cracking and creep of the concrete. In TQS, it is possible to simulate the interaction between the infrastructure and the superstructure in the model, in which the foundation and soil elements are discretized together, with the spatial frame taking into account geotechnical aspects. TQS has a modal analysis and a time history analysis, in which the dynamic effects of actions can be calculated in order to verify vibration limits. It is also possible to evaluate user comfort in the face of wind gusts. TQS has spectral modal analysis for simulating the effects generated by earthquakes. It also has a model called physical and geometric nonlinear frame, in which physical and geometric nonlinearities are considered in a refined way. being useful for analyzing specific structures or elements. Ultimately, the resources present in TQS provide the engineer with a precise, reliable, and transparent structural analysis. To learn more about TQS, visit our website. Thank you.